So starting on page 2 in like the middle, using the Pythagorean Theorem, this is called the inequalities theorem. Basically, you can just use the Pythagorean Theorem to decide if you have an acute, right, or obtuse triangle. So, your book, if you remember, your book wrote it c squared equals a squared plus b squared, and we thought that was extra. Here's why they did it. We're not going to do it that way still. If you wrote it this way, you could literally just throw in a less than sign, and if c squared was less than a squared plus b squared, then you had an acute triangle. If c squared was greater than a squared plus b squared, then you have an obtuse triangle. I'm just going to teach you the property behind it, and then you could just make your decision from there. So you have a box. You're going to fill this into the box. You'll have an acute triangle when the hypotenuse squared is smaller than the leg squared plus the leg squared. So you will have an acute triangle when the hypotenuse squared is less than the leg squared plus the leg squared. So you'll have an acute triangle when the hypotenuse squared is less than, or smaller, however you want to say it, than the leg squared plus the leg squared. Then the opposite, if the hypotenuse squared is larger than the leg squared plus the leg squared, then you have obtuse. So you're comparing the hypotenuse squared to the legs. So, this is the set of questions that you have. It says to first verify that the segment lengths form a triangle. We learned this in chapter 6. To do that, you take the two smaller sides. Them added together need to be larger than the biggest side. So let's practice this for a second. Give me 3 numbers. Any 3.
12, 1, and 2.
12, 1, and 2. You take the two smaller sides, which would be 1 and 2. Them added together need to be bigger than the longest side. So 1 plus 2 is 3. Is 3 bigger than 12? No. So this wouldn't be a triangle. Let's see if this would be a triangle. What are the two smallest sides? 11 and 2. 11 plus 2 is 13. So 13 is bigger than 12. So it would be a triangle. So whenever you see verify the segment lengths form a triangle, add the smaller ones to see if they are bigger than the biggest one. From there, we're going to decide if it is acute, right, or obtuse. Okay, so we're going to verify on the first question. I always just write it above. You can write it wherever you want. But we're going to take the two smaller sides, which would be 90 and 216. What is 90 plus 216? 306. Is 306 bigger than 234? Yeah, it is. So this is a triangle. Now we decide what kind of triangle using the Pythagorean Theorem. A squared plus b squared equals c squared. So in the past, I used to write a blank here instead of like an equal sign because we don't know if it's equal to, we don't know if it's less than or greater than. But then students don't remember like the actual property, so I don't know. I'm going to put an equal sign as a placeholder until we decide if it's less than, greater than, or equal to. So what are A and B going to be? 90 and 216. And then the biggest side, C, which is 234. 90 squared is 8100. What is 216 squared?
What is what?
200. 46,656?
Yes.
And then 234 squared. 54,756. So now we combine on the left and then we compare it to the right. So Add 8,100 and 46,656, and we get 54,756. So what kind of triangle is this? It is a right triangle. All right, and then number 9, again, we've got to verify. We need the two smaller side lengths and see if they're bigger than the longest side length. We've got a 1 and a 1 and a square root of 3. What is square root of 3 approximately? Yeah, it's about 1.7. So we would need to know that 1 plus 1 is bigger than the square root of 3. What's 1 plus 1? 2. Is it bigger than the square root of 3? Yes, so this is a triangle. So then we're going to use a squared plus b squared. And again, the equal is just like just sitting there because these aren't going to be equal, but we're just going to keep it as a placeholder. Which of these is going to be c? The biggest side, which is the square root of 3. You don't need parentheses here because there's no number in front. It's when you have like a number in front you need parentheses. But we don't have one, so you can put one there if you want, but you don't need to. A and B are going to be 1 and 1, which is pretty easy. What is 1 squared? Yeah, 1 and 1. 1 plus 1 is 2. The square root of 3 squared is 3. They cancel each other out. So here we're going to compare the hypotenuse squared. If the hypotenuse squared is smaller than the leg squared plus the leg squared, then you have an acute triangle. If the hypotenuse squared is larger, then you have an obtuse triangle. Which of these numbers represents the hypotenuse squared? 3. Is it smaller or larger? Larger. So this is obtuse. Good. So that was the last property. From here we just review what we learned yesterday. On the next page. Sorry, I'll wait a second. Find the value of x, then tell whether you have a Pythagorean triple. So you have two sides on a right triangle. We're looking for the third. How do we find the third side? Yeah, a squared plus b squared equals c squared. Good. The Pythagorean theorem. So anytime you have two sides and you're looking for a third, you're using the Pythagorean theorem. Which of these sides is going to be c? Yeah, 25. It's across from that right angle. So we will have 15 squared plus x squared equals 25 squared. 15 squared is 225, yeah. 25 squared, 625. Oh my gosh. What is 625 minus 225? It's definitely Trayon. What is the square root of 400? 20. Is this a Pythagorean triple? Yes, all of the side lengths are whole numbers. Alright, second example. The flagpole shown is supported by two wires. Use the Pythagorean theorem to approximate the length of each wire. So if you look, they're just two right angles that are identical to each other. So you could just focus on one of them. We need to find the length of x, the support wire. We know 8.5. What is the length of the pole? 15.1, yeah. It's this. So 15.1. Alright, so again, we're going to use the Pythagorean theorem. So A and B are 8.5. I can't focus. And 15.1. And we're comparing it, or we're setting it equal to x squared. You are going to get decimals. You should not round in the middle of a problem. If you round in the middle of the problem, then you add the rounded number, and then you take the square root of the rounded number, and then you round that rounded number. It's a hot mess. So if possible, do not round. What is 8.5 squared? 72.25. And 15.1 squared?
228.01.
228.01, you said? Add them together. We get 300.26. Last step is to take the square root to cancel out that squared. And what is the square root of 300.26? 17.1 feet. Alright, we do one more. I know my screen says 2, but I moved this to the next week so we can just review it then. Tell whether each triangle or this triangle is a right triangle. We will use the Pythagorean theorem to decide. So a squared plus b squared needs to equal c squared in order to have a right triangle. So we need to first figure out what c would be. Which of these is the longest side? It is 12. If you don't know for like this side length, you can always type in the square root of 5 and then multiply it times 4. It's about 8 point something something. That's just to see its value and just to see that it's not the longest side. We're going to plug in 8 squared. And then for this one, you will need parentheses. 4 square root of 5 squared. 8 squared is 64. 4 square root of 5 squared. So I always just put a dot between them so we know we're multiplying them. And then I'm going to distribute the square, if you will. We're going to square both pieces. 4 squared is 16. The square root of 5 squared is 5. 16 times 5 is 80. And then 12 squared is 144. What is 64 plus 80? 144 equals 144. Is this a right triangle? Yes, right triangle.